Good morning, everybody. Today is Monday, March 1st, with first day of March. This is nutso. We only have just a couple more months left, and that's it. Hey, today is just let me look at our objective with you. This video is for those of you who are absent today, and it's meant to just be a really quick overview of what we did. There may be some things that I would like you to do, and so watch the entire video. I'll try to keep it under 10 minutes. And just so that when you do come back, you're ready to go. All right, so the objective today is the student will use models to answer the investigation question by by observing that a chemical reaction will involve like a rearrangement of atoms to form different substances. Let me take you quickly into my PowerPoint. So the kids today did the warm-up, and the warm-up is asking them to open the sim. So this warm-up takes a little bit more time, and you're going to use the sim to test whether or not a chemical reaction can happen with only one substance. Yesterday, we saw that a chemical reaction occurs when we add two substances together, and of course, two or more substances, but we're curious to see, can a chemical reaction occur with just one substance? Can one substance change into a different substance or substances? And so follow the directions for the warm-up. I think it's pretty interesting, and I think you'll be maybe surprised at what you find out. So we went ahead and we'll discuss that. I am going to do a little spoiler alert. Yesterday, we saw that claim number 3 could be correct because claim number 3 is saying the iron pipes and the fertilizer together changed into rust. And we saw that two chemicals yesterday, we poured two chemicals that had been dissolved in water, and we poured them together into a third cup just to see what would happen. And we saw that those two liquids turned into two different solids, salt and chalk. And so that evidence leads us to believe that claim number 3 is possible. And in the warm-up, you're going to find out that one substance actually can change into a different substance under the right conditions. Okay, so that suggests that claims number 1 and number 2 are also possible. So right now we're sitting here going, okay, we could argue claim number 1, number 2, and number 3. So we need more evidence. The investigation question today is, how do substances change into different substances during chemical reactions? When we're in the sim, I want you to really pay attention to what's going on down here. It'll say testing conditions, they have to be dissolved in water, or they have to have electricity and they're at room temperature in order to cause that change. So pay attention to that. What you're going to do is you're going to go into the sim, and you are going to go into laboratory A, and you'll test different substances. So you're just going to randomly pick two chemicals and see what happens. Will they always, if I put two chemicals together, will they always result in a chemical reaction? So you're going to ultimately, you're going to ultimately find some that do and some that don't. And I want you to pay attention to what happens to those that do. It says for each test, you'll rewatch the atomic scale animation, discuss whether or not a chemical reaction occurred. This will help you with your question. The key concept number 5 that we had yesterday, I just take a second to remind the kids about that during a chemical reaction, remember, we have one or more starting substances. That's the reactant, and that's on the left side of the arrow. And they change into two or one or more different substances on the right side of the arrow. So go ahead and do the sim activity. This is lesson 2.2. It's going to be activity number 2. Just follow the directions and then answer any of the questions that are on there. And we just took some time in class to talk about what happened. And then we had an activity where we took these two cards. These are laminated cards. And the partners, one partner had card A, one partner had card B. They used these little tokens to put on top of the reactants and then demonstrate how the reactants those chemicals actually there's like a two-step process. They have to, number one, they break apart. The bonds have to break apart, and then they rearrange to form the product. And the key here that I really stressed with the kids is they only have enough tokens in these cups to cover these. So they've got 5 tokens in their cups, one for hydrogen, one for chlorine. And then over here for the sodium hydroxide, they've got sodium, oxygen, and another hydrogen. And that's all that they have in their cup. Actually, it's not all they have in their cup, but they're going to understand that they don't need any of those extra ones. Because when these bonds break and then they rearrange into the new substances, the new products, so water and sodium chloride, water and salt, they will realize that they don't have any extra tokens left over to put back in their cup, and they didn't need to take any tokens out from the cup. And the big thing that we're going to talk about today, and this kind of is included in chapter 3 also, but it's the law of conservation of matter. And what that means is that atoms, and we've talked about this in class before, atoms do not come from nothing and they don't magically disappear during a chemical reaction. In other words, whatever atoms I have in whatever arrangement I have over here, when these bonds break, they'll rearrange using those exact same atoms, same number of atoms, but they're going to be in a different formation, which goes along with key concept number 3 that says substances are different because they have different groups of atoms, and the atoms are arranged in different groups. So conservation of matter, and that is that matter is not generated or it does not disappear in a chemical reaction. Whatever we have to start with, that's what we have to end with. Okay? So I am just running through really quick, make sure I'm not losing anything else. I think that was it. Yep. Okay, I'm going to let you pause the video and write down key concept number 6. And key concept number 6 says, during a chemical reaction, atoms do not change from one type to another. Super important. We don't have an oxygen that turns into something else. If the oxygen is on the reactant side, it will be over on the product side. I'm going to go ahead, pause the video and copy that down. Okay, and then we have key concept number 7, and that says during a chemical reaction, atoms rearrange to form different groups of atoms. Go ahead and pause the video and write that down. Okay. So now we can answer our investigation question. How do substances change into different substances during chemical reactions? And I made the kids write this down just on a note paper. There are 2 steps, and it's important that you start thinking about this chemical reaction and the changing of the substances in 2 steps. Number 1, the groups of atoms break apart in the reactants. And number 2, they rearrange to make the product. So they break apart and they rearrange. Break apart and rearrange. Okay, vocabulary that we talked about today, chemical reaction. It's a process in which atoms rearrange to form a new substance. And then the vocab word rearrange, it means to change the order or position of something. But remember, we're also really stressing that no new atoms are coming in and no atoms leave at all. They're just rearranged. Okay, this is a good diagram to demonstrate how atoms from the reactants break apart and rearrange to form products during a chemical reaction. Notice these bolded words are your vocab words. So this is just kind of a example of how you can use your vocabulary words in an explanation. And that's it. Hey, I hope to see you guys soon. Just to let you know, some of you guys who have been gone, I am going to be gone Thursday and Friday. My dad is not doing very well, and so I'm leaving to go spend some time with him. And so I will be gone Thursday and Friday, And then Monday, we do not have school because of boys basketball. So if you are gone for the rest of the week, I won't see you until next week. All right. So please, please email me if you have any questions. If you're a little bit worried about what's going on, you're not following, let me know. Okay. Take care. Talk to you later.